All right, so today we're going to be talking about rotating regions around lines other than the x-axis, because we can basically rotate anything around any line that we want to. So we're going to start off by rotating the region enclosed by y is equal to 2 minus x squared and y is equal to 1 around the line y is equal to 1. So I've done a little bit of front loading here. I've graphed the two functions. That's my y is equal to 2 minus x squared. This is my line y is equal to 1. I found my two intersection points by putting these two functions equal and solving. So that's telling me that the two graphs are meeting at the x value of -1 and the x value of +1. Those are going to end up being our bounds on our integral. So basically what I want to know is if I take this region, so this region with the 2 minus x squared on the top and that y is equal to 1 on the bottom, and I were to rotate this stuff around the line y is equal to 1, I want to know what its volume is. So I'm just going to kind of like take the region down here. I'll talk about why I'm doing this a little bit later. It's definitely going to make a difference on our math when we rotate regions based on their direction. So my region that I'm rotating right here, I'm going to say that the upper part of it is my 2 minus x squared and the lower part is my y is equal to 1. And we'll see why this is important in a second. So if I were to take this region, I'm going to kind of erase these little tail ends here because I don't really need them, around the line y is equal to 1, it's going to end up looking somewhat like football shaped. So if I were to kind of replicate this part of the graph down there and kind of take out a cross section, the cross sections are still going to be like cylindrical in nature. I want to keep this part in mind when I'm doing this part, because in the last video when we were rotating about the x-axis, our radius of our cross-section or our cylinder was always just the function. But now that we're rotating around a line other than the x-axis, our radius is going to be changing. And this piece is going to be really important to determine what the actual radius is. So if I were to think about what's happening here, the radius of this cylinder here is going from my top piece down to kind of my horizontal line here. So I'll draw that separately down here. What that's basically going to look like is the radius ends up starting up here at that 2 minus x squared. Oops, 2 minus x squared. And the radius ends down here at the line y is equal to 1. So when I'm going to plug into my general volume formula, which still hasn't changed, it's still the pi on the outside times the integral from a to b of whatever the radius is squared times the delta x, because remember the volume of a cylinder is just pi r squared h. There's the pi, there's the r squared, that's the h. Remember that that's really just representing the delta x. So when I go to plug into my radius over here, like I said, it's not going to be the same as what we were doing the other day. The radius is now going to be taking the difference between the upper part of my region minus the lower part of my region. So my radius here actually is going to be the 2 minus x squared that's happening on the top minus the 1 that's happening on the bottom. So if I were to simplify this a little bit, 2 minus 1 just gives me 1 minus x squared is the radius value for this solid that's happening. So when I go to plug in over here, my volume is going to be pi times the integral from my intersections, which we already found up here, so -1 to +1, of the radius of 1 minus x squared squared times delta x. And again, you can just use whatever the online virtual calculator is that you have, or if you have the 83 or 84 at home. I just went through, plugged this in. So integrate from, or pi times that quantity squared from -1 to +1. And that's going to give me approximately 3.3510. And that would be the volume of that region rotated about the line y is equal to 1. All right, so I'm going to go through another example. I'm going to try to do probably 4 or 5 examples with you guys on this, because it really depends on what the function is and which way we're rotating, and hopefully seeing more examples will help you guys out a little bit more. So now example 2 is asking me to revolve the region of y is equal to the square root of x. from x is equal to 1 to x is equal to 4, and I'm going to be rotating this about the line y is equal to 1. All right, so I'm going to draw myself a sketch of what this graph is going to look like. So if I'm drawing a square root graph, I need to get up to an x value of at least 4 to do a little rough sketch here. So there's my square root graph. But I'm bounding this from x is equal to 1 to x is equal to 4, and I want to rotate about the line y is equal to 1. So I'll draw my line y is equal to 1 here. It's not very accurate. Fix that a little bit. That should be where my 1 is. All right, so basically I want to rotate from here to here, this region enclosed by the square root of x and that line y is equal to 1. So this is going to be the stuff that I'm actually rotating. And if I were to take that and rotate it about that line, I would end up getting something that would look like this. So there's my kind of like revolved region, if you can kind of imagine that a little bit. So again, I'm going to kind of just redraw this region here. So the top part is my square root of x, the bottom part is my 1. So when I'm going to actually decide the radius of this cylinder that I'm taking out, the face of it, my top part would be my square root of x, my bottom part would be my 1. So my radius is my top, so square root of x minus my bottom, so square root of x minus 1. So when I go to plug that into my volume, so I'm going from the x value of 1 to the x value of 4, so those are going to be my limits on my integrand here, and I'm going to take that square root of x minus 1 squared dx, and I'm going to go ahead and evaluate that on my calculator here. So pi times the square root of x minus 1 squared from 1 to 4. And you should get about 3.6652 for your volume. All right, I'm going to keep on going here. So example 3. Okay, example 3, we're going to be talking about the rotating the region of y is equal to x squared plus 3, x is equal to -1, and x is equal to 2, and y is equal to 1. So this one has a bunch of restrictions, and we want to revolve about the line y is equal to 1. All right, so I'm going to go ahead and make myself a quick little sketch here of what this is going to look like. All right, so x squared plus 3, here's my vertex. I'm going from the x value of -1, the x value of +2, and y is equal to 1. All right, so if I were to draw some points in here, so 1 squared plus 3, that'll give me a 4. So I'll just do my quick little reflection here. And then 2 squared is 4 plus 3 gives me 7. So my other point's going to land somewhere up here. So this is going to be what my parabola is going to look like. And the region is actually going to be enclosed between x equal to -1, x equal to 2, and y is equal to 1. So I'll draw myself a y is equal to 1 here. And a little bit off on there. So basically what this ends up looking like is my region is actually in here. So my region, if I kind of take that out and draw it separately, ends up looking something like this. So the top part here is the x squared plus 3. The bottom part here is 1. And if I were to take that and revolve that about this line, y is equal to 1, I'll just kind of draw myself a quick sketch of what that's going to look like down here. It's definitely not going to be very accurate, but hopefully you'll get the idea. So that's what my solid is going to end up looking like if I were to revolve that. My cross section here, again, going to be cylindrical in nature. I'll do my radius work up here. So if I were to take that out, the radius, or the top part of my radius, would be the x squared plus 3. The bottom part of my radius would be the 1. So my radius is going to end up being x squared plus 3 minus 1. Oops. So if I simplify that a little bit, it's going to be x squared plus 2. So that's going to be what I want to actually put into my integral. So my volume is going to be pi times the integral from my x value of -1 to my x value of 2 times this x squared plus 2 squared delta x. I've already done that on my calculator here. So when you do that on whatever the calculators that you choose to use, you should get about 96.1327 for your volume. All right, a couple more. So my next example, I'm going to go back to the square root, but this one's going to be a little bit different than the one that I just talked about in the last example. You'll see why in a sec. So now I want to revolve y is equal to the square root of x minus 1, bounded by y is equal to -1, x is equal to 4, and I'm revolving that about the line y is equal to -1. So I'll start off by drawing myself a quick little sketch here. So I know my graph is shifted, the square root of x graph is shifted down 1 unit. This should be at 0, and then I'll do a point at 4. So square root of 4 is 2 minus 1 should be the 0.41. This is going to be what my square root graph looks like. I'm bounded by y is equal to -1. Well, that's where y is equal to -1, so that's really telling me that this is an x value of 0. And then I want to revolve about the line y is equal to -1, so I'll sketch that in as well down here. So the region that I want to actually revolve is going to end up looking something like this. So here's my region down here. My top part is the square root of x minus 1. My bottom part is -1. And if I were to kind of replicate that down, I'm going to kind of go into my writing down here. But this is going to end up being the region that we want to get the area of. So again, here's my cross section, here's my radius, not very accurate here. But when I look at the radius of this, and I were to kind of sketch out that circle again, that face of that cylinder that's happening, my top part is the square root of x minus 1, my bottom part is -1. So when I go to actually calculate the radius, that's going to be the square root of x minus 1 minus that bottom part of -1. So we end up getting something like the square root of x minus 1 plus 1, which actually just ends up being the square root of x. I don't know if you guys can see that with my leg in the way here. So when I plug that into my integral, my volume is going to be pi, and I'm starting my x value at 0, because that's where that y was equal to -1, and I'm going up to the x value of 4, so from 0 to 4, and then I'm going to go ahead and plug in my radius, square root of x squared dx. If I simplify that a little bit, that's really telling me that's pi times the integral from 0 to 4. Well, the square root of x squared is just x dx. So when you plug that into your calculator, again, I've already done the work here, you should get approximately 25.1327. And that should be the volume if you were to rotate this region about the line y is equal to -1. And again, with the radius work, just be careful with the negatives. Make sure that you're getting that double negative, because that will definitely make a difference when you go to plug back into your volume. All right, we will do one more together. This one's a little bit different. So this one is going to be talking about a parabola graph, but now we're going to be rotating in a different way, which we'll see in 1 second. So we want to revolve the region bounded by y is equal to x squared and y is equal to 2. And I'm going to revolve that about the line y is equal to 2. So I'll make myself a quick little sketch here. So, all right, a couple more tick marks up here. So x squared, so 1 squared is 1, 2 squared is 4. So this is what my y is equal to x squared curve is going to look like. And this time I'm bounded by the line y is equal to 2. So I'll go ahead and draw in that vertical line. And this is going to end up being the region that we want to revolve. and we're revolving it this time, it's going to look a little bit different because the other ones were revolved down. This one we're actually going to be revolving upwards since the region is below that line. So the purpose of drawing out the region is actually really important, like in a case like this, because the region on the top here is actually the horizontal line, and the region on the bottom is the x squared piece. So when we were, or if we were to take that and revolve it, it would end up looking something like this. And if you kind of think about what that's going to look like in terms of like actually revolving it about that line, you're going to look like, or get something that looks like a bowl, but it's going to be like filled in. So when I go to actually calculate my radius, I know we've been kind of like working from the top down, but this time, like I said, our top region bound is actually 2. The bottom region bound is actually x squared. So when you go to actually do that radius, since you're revolving it up, we want to kind of calculate the radius almost going down. So the top part is 2 and the bottom part is x squared. So when I go to plug in my radius, the top part is 2 minus the bottom part of x squared. So the radius is actually 2 minus x squared. And again, that's different because the upper bound of this function was the horizontal line and the bottom bound of the function was the parabola. So what is that going to look like in terms of volume? Well, we're still using the same. Volume is equal to pi times the integral from, let's see, we're working from the x value of 0. Oh, I haven't actually found out what that corresponding x value is. I know its y value is 2, so I'm actually going to need to find the intersection point here. Let me erase this. So when I set x squared equal to 2, set these two equal to get the intersection points, if I take the square root of that, my x value is going to either be plus or minus the square root of 2. Well, obviously we're only working in the positive direction here, so my intersection point would be the square root of 2. So I'm actually working from the x value from 0 to the x value of root 2. And we said that the radius was 2 minus x squared. I'm going to square that, dx. And again, you can just plug that into your calculator. Again, bring the pi on the inside there when you calculate it. You should get a volume of approximately 9.4782. All right, so I'm going to give you guys some practice problems to try. Do your best to work with these. If you have any questions, please make sure that you contact me.